Equations.
Hopefully they're simple.
They are pretty simple. Someone raise your hand and explain to me what my ultimate goal is when I'm solving an equation.
Get the answer. Find the answer.
Find the answer. Or give me something a little more specific.
To find the answer to the problem.
Find the answer to the problem. Yes.
This
What is in an equation that starts with the letter V? Variable. So what were you going to say? Find the variable, right? I want to isolate the variable on one side of the equation. So my ultimate goal is to get the variable by itself on one side of the equal sign, correct?
Yes.
Yes. Okay, very good. So, you may have heard this explanation before, but I like it. It's a good analogy. You know those scales that kind of one side goes up if you add more weight to it?
Yeah.
So I like to think of equations like a scale.
I'm waiting.
Okay? So I like to keep them perfectly balanced because it starts off balanced because it says one side is equal to the other side, correct?
Mm-hmm.
So that means they'd be at the same height. What happens if I add 5 pounds to this side over here?
Hey, that one go up. I mean, no, that one go up.
This side goes up, this side goes down, right?
Because it get heavy.
Okay, quit talking, pay attention. If I add 5 pounds to this side, it's going to go down, right? So what do I have to do to make it level again?
Add 5 pounds to that side.
Add 5 pounds to this side. If I take 5 pounds away from this side, it's going to go up.
Yep.
So I have to take away 5 pounds from this side to make it even.
Yep.
If I multiply this side by 5, I've got to multiply this side by 5. If I divide this side by 5, I've got to divide this side by 5, right?
Yep.
That's the same thing with equations. Whatever I do to one side, I have to do the exact same thing to the other side of my equation. Is everyone remembering this from pre-algebra? Hopefully.
Yep.
No.
I am.
But does that make sense, though?
Yes.
Does that explanation make sense?
Yes, sir.
Okay. We move things around in our equations using things called inverse operations. Have you heard of those before?
Yeah.
What's the inverse of addition? Subtraction. What's the inverse of subtraction?
Addition.
Addition. What's the inverse of multiplication?
Division.
Division. Inverse of division?
Multiplication.
Multiplication. Everyone got those down?
Yes.
Perfect. So let's look at our examples. Solve each equation. Check your solution. So number 1, I have x minus 3 equals negative 5. X minus 3 equals negative 5. Do we have a question? Okay. So as it is right now, the left side of my equation equals the right side of my equation, right? That's what the equal sign means.
Yeah.
So I got to keep both sides equal throughout the whole thing. My ultimate goal is to get the variable by itself on one side of the equation. Is that the case right now as it is? Is the variable by itself, with nothing else around it on one side of the equation? No.
No.
What number is on the same side as the equation? 3.
Negative 3.
What operation is going on between x and 3?
Subtraction.
Subtraction. Bless you.
You're welcome.
What did we say was the inverse of subtraction?
Addition.
Addition. Very good. So what do I need to do here to get my x isolated by itself on one side of the equation?
Bring add the 3 with 5. I mean.
Someone raise your hand. Yes.
You add 3.
Add 3. Very good. I'm trying to get the minus 3 away from x. So we have to use our inverse and add 3. That helps me because negative 3 plus 3 is what?
6.
Negative 3 plus 3 is 0. It just cancels out, right? That's how I get my x by itself over here.
That's how you do it?
But like we said, whatever I do to one side of my equation, I have to do to the other. So I've got to add 3 to this other side. What's negative 5 plus 3?
Negative 2.
Negative 2. So I kept my equation equal throughout because I did the same things on both sides, right?
Yes.
Is my variable now isolated by itself on one side?
Yeah. Oh, I broke.
Yes, it is. So I have now solved my equation. Questions there? Am I done on number 1 or do I have to do something else?
Something else.
You are
done.
No.
You have to do something else.
What do I have to do?
You're done.
What do the directions tell me to do?
Check your solution.
I have to check my solution if it tells me to. And checking your solution does not consist of typing it in your calculator and saying, oh, yep, it looks good to me. That's not what I mean by check your solution.
Okay.
I want to see it on your paper.
Okay.
How do I check my solution on paper?
Subtract.
Opposite.
Addition.
I think.
Anyone?
Multiply.
Hold on. Please just stop throwing stuff out there. Anyone know how to check a solution on paper?
You write out the problem with the variable filled in.
Very good. I'm just plugging in what I got for x into my original problem. So x minus 3 equals negative 5. I'm replacing the x with negative 2. And then I write the rest of the problem exactly the same. Does everyone see that?
Yes, ma'am.
Okay. When I'm checking my solution, I am no longer trying to move stuff around, trying to get something by itself. I'm just looking at each side of the equation and working each side down. So is my left side completely worked out? There's no more operations I can do?
Yeah.
There is an operation I can do, right? What's negative 2 minus 3?
It's negative 5.
Negative 5.
Do I have one?
Is the right side of my equation completely worked out? Yes, it is, so I just bring it down. When I'm checking my solution, I'm checking to see if I get a true or false statement when I plug back in. Is this a true or false statement? Negative 5 equals negative 5.
That's true.
That's true. It checks out, so I know my answer is correct. If I got a false statement, my answer would not be correct. I'd have to go back and see what I did wrong. Yes.
So, I forgot it.
Okay. So I do want to see this on your paper if it tells you to check your solution.
Oh, that's what I'm saying.
Does everyone see?
That's what
On your assignment, I also want to see your steps. I want to see your work. So if this was on your assignment, I would want to see plus 3 and plus 3 on both sides of the equal sign. I want to see all your work. That's never going to change. Always, always, always show your work. Any questions?
Yeah.
Some of you may be like, oh, but Mr. McAllister, I did it in my head. I know how to do it. Well, if you can do it in your head, you can write it on paper, right?
No.
Yes.
Yes, you can.
What type tab?
So, are there any questions on number 1?
No.
Shh. Can I move on to number 2?
Yes, sir.
Okay. I have 0.9 equals y plus 2.8. 0.9 equals y plus 2.8. So is my variable isolated by itself with nothing else around it on one side of the equal sign?
No.
It is not. What number is with it?
2.8.
2.8. What operation is going on between y and 2.8?
Addition.
Addition. What is the inverse of addition?
Subtraction.
Subtraction. So what am I doing to both sides of my equation?
Subtract.
Subtracting
2.8.
2.8. When I subtract 2.8 from over here,
Uh-oh. Whoa.
it cancels out.
Yeah.
Whatever I do to one side, I have to do to the other. 0.9 minus 2.8 gives me
Negative 1.9.
is y now by itself?
Yes.
Yes, it is. If you wrote it as y equals negative 1.9, that's correct as well. You can write it like that if you want. Checking our solution, just plugging back in.
It is right. It is right. It is right.
Okay, is the left side of my equation already worked out?
Yes.
Yes, it is, so I just bring it down. Negative 1.9 plus 2.8.
Huh?
Negative 1.9 plus 2.8.
0.9.
0.9. True or false statement?
True.
True.
True. So I know my answer of negative 1.9 is correct.
I got a question.
Yes.
So will we have false ones?
If you got the wrong answer and you plugged in, it would be false.
Okay.
So let's say you accidentally added these two numbers and you got positive 3.7 for your answer. I try to plug 3.7 in here. That's going to give me 6.5 equals 0.9. It's a false statement, right?
Yeah.
So I know I messed up on solving my equation, so I got to go back and find my mistake. Okay? Any other questions?
That's a good way to find out how you learn.
It is a good way to find out. Can I move on to my last slide?
Yeah.
We should multi-step.
Oh, Lord.
Wow.
Okay, letter A. I've got negative n over 5 equals negative 3. Negative n over 5 equals negative 3.
Negative.
Oh, I know.
Is my variable completely isolated by itself on one side of the equation?
No.
It is not. What number is with it?
5.
5 or negative 5, right?
No.
What's the operation going on between n and negative 5?
The big.
Division. If you see a fraction bar, that's just division. Okay? So what's the inverse of division?
Multiplication.
Multiplication. So, to get rid of the negative 5, I need to do what to both sides?
Multiply.
Multiply by
5.
Negative 5.
negative 5.
Negative.
When I multiply by negative 5, it cancels out. Whatever I do to the left, I have to do to the right side.
Negative 3.
So I get n equals, what's negative 3 times negative 5?
15.
Positive 15.
So,
Questions how I got that?
no question.
We all right? We all understanding this? No?
Yeah, we are.
A little bit?
Oh, I was going to tell you had this.
Okay, plugging in. Negative 15 over 5 equals negative 3. Got to work out both sides of my equation. What's negative 15 divided by 5?
Negative 3.
5.
Negative 3.
Oh. Oh, that's wrong.
True or false statement?
True.
True.
True. So I know my answer of 15 is correct.
Correct.
Questions on A?
No.
Am I moving too fast for anybody? I can slow down if I need to.
Okay.
Can I erase A and move to B?
Yes.
Okay, letter B, I had a typo, so I had to rewrite it. It is pi x equals negative 2 pi. Those are pi symbols. Sorry if you can't tell. Pi x equals negative 2 pi.
2 pi.
Okay, so let's talk about pi real quick. What is pi? 3.14159, so on and so forth. It just keeps going and going and forever and ever and ever, right?
Yes.
But pi is just a number, right?
Yes.
A mistake that a lot of students make is whenever they see the pi symbol is they try to treat it like a variable. Is pi a variable?
No.
No, pi is just a number. We just use a symbol to represent it, so we don't have to write a big old long decimal. So I just have pi x. Pi is just a number. Pi is with x on one side of the equation, right?
Right.
What's the operation going on between pi and x?
Multiplication.
Multiplication. Inverse of multiplication?
Divide.
Division. So I need to divide both sides by
2.
pi.
Oh, no.
Remember, I'm trying to get the x by itself, so I want to divide by the thing that's with x. Does that make sense? So pi is with x, so I want to divide by pi to get rid of it.
How you gonna do that?
It just cancels out when I divide by it.
I mean, like, when you on the other side.
Huh?
I mean, like, when you on the other side.
Well, if I divide by pi on one side, what do I have to do to the other?
Divide by 5.
Divide by pi. What happens over here?
Cancel
It cancels
My
out.
pi cancels out. What am I left with?
2.
Negative 2.
Negative 2. Oh, yeah, that was easy.
Does everyone see that?
Can you not?
Checking. Do what?
Oh, from the outside, you check it.
Well, I'm just plugging negative 2 into my original equation. So pi times negative 2 equals negative 2 pi. If I have pi times negative 2, that's the same thing as negative 2 pi.
It's the same thing.
Is that a true or false statement?
It's true.
True. So I know my answer of x equals negative 2 is correct. Any questions on that?
No.
We all understand?
Yes.
Can I erase B and move to my last example?
Yes, sir.
1.3z equals 5.2. Someone raise your hand and walk me through this whole process all the way until we get the answer.
Okay.
And
So-
explain each step as you go through it.
Okay, so you go divide 1.3, right?
Where?
Both sides.
Both sides. Very good. Z is being multiplied by 1.3. So to get rid of it, I divide by 1.3.
That cancels out.
Cancels out. I got to do the same thing over here. What do we get? Z equals
4.
4. Very good. Questions how we got that? Plugging in. 1.3 times 4 equals 5.2. Working down both sides. What's 1.3 times 4?
Whoa.
5.2. My right side's already worked out, so I just bring it down. Do I get a true or false statement?
True.
True. I know Z equals 4 is my answer. Questions on C? Questions about any of the notes we just took? We all understand it? Was I correct when I said it was decently easy? Okay.
I thought you was
Decent.
What's our homework?
Can I move on to my assignment now?
Yeah.
All right. Okay, we've got page 20, number 6 through 30 evens. If you've never seen it like this before, this is what I mean by 6 through 30 evens. On the problems 6 through 30, you're only doing the even numbers. So you're doing problem 6, problem 8, probably 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. That's 13 problems. You're skipping all the odd ones. Does that make sense?
Yeah.
Okay, this will be due Wednesday, August 25th on Canvas. Are there any questions before I end my recording?
Wait.
Yes.
So I don't do my previous math work from a different class.
You have that work?
Yeah.
We'll figure out what we're going to do with that. Okay,
I wasn't aware of my schedule until last time.
gotcha. Yeah, we'll figure it out. Any other questions before I end my recording?